In science, there are these wonderful formulas that describe our world. For example, one you can think of right away. In a collision, there's an 18-wheeler going against a smart car. The smart car is my fist. The 18-wheeler is my entire arm. If they're both going the same speed, who's going to win? It's pretty easy to know. That's the concept of momentum. Momentum is symbolized by the letter P, and then M is mass, and V is velocity. So the amount of momentum you have is dependent on how much you weigh and how fast you're going. So if they're going the same speed, well, there's a whole lot more mass in the 18-wheeler, so that's why the 18-wheeler beats the smart car in the accident game, I guess, if we want to call it that. P equals mv. Now, sometimes we don't want to know what P is. Sometimes we already know the momentum and we want to know the mass or the velocity. But how do we solve that? There aren't any numbers here. We know enough algebra right now to solve for any of these variables. For example, let's say that the goal was to solve for mass, because we already knew the momentum and the velocity, and we were trying to solve for the mass. Well, what's happening to mass in terms of operations? Is it being added by V? Is it being subtracted by V? Is it being divided by V? Or is it being multiplied by V? Well, you know, when two letters, two variables are back to back like this, that operation is multiplication. So we know that it's M times V. Now, how do you solve for any variable? Well, you have to be fair, and you have to do the opposite. So to be fair, draw upside down T to make sure that whatever we do to one side, we do to the other side. So we have M times V. So we're going to do the opposite operation, which is division. And we'll divide by V, and whatever we do to one side, we do to both sides. V divided by V, just like any number divided by itself, is 1. So you're left with 1m equals P divided by V. And 1 times m is, of course, just itself. Anything times 1 is itself. So m equals P divided by V. So in this case, if you wanted to solve for mass, you'd put momentum divided by velocity. Let's look at a different equation. Our friend, the triangle. We can solve for the area of a triangle by utilizing the area formula. The area of a triangle, area equals base times height divided by 2. Well, let's say this time we were given the area and we wanted to solve for the height. So I'm going to circle height. Let's solve for height. But goodness, that looks more complicated than the last one. Oh, it's divided by 2. It's a fraction. And I know how to eliminate fractions. I simply multiply by the denominator. I know. If I multiply by the denominator, and whatever I do to one side, I do to the other, the denominators cancel themselves out. And you're left with 2a equals bh. Ooh, we are close now. Really, really close. We are solving for h. So what is happening to h? Is it being added, subtracted, multiplied, or divided? h is being multiplied by b. So what we will do is the opposite operation. We will divide both sides by b because we're solving for h. The b's cancel themselves out because anything divided by itself is just 1. You're left with 1h equals 2a divided by b, and 1 times anything is itself. So our final answer is the height is the same thing as saying twice the area divided by b. So you're going to run across formulas and equations that describe our world, and we're not always going to have numbers attached to them. In order to solve for any given variable, you utilize this same line of thinking you've already done. You're supposed to be fair. You're supposed to eliminate fractions by multiplying by the denominator. You're supposed to utilize distribution when necessary. And if you utilize all of those strategies, you'll be able to solve for anything, even if there are hardly any numbers. Yeah, that letter, mostly letters here. And P equals MV was all letters as well, but it didn't matter. You've got the skills to solve for any variable. Thank you. Have a great day.